Okay, I think we'll start this session. Is biochar a growth area for conservation districts? Pretty excited about this one. This is part of 7 webinars that NACD is hosting today. And this one is a good example of something exploratory. In May, I was part of an exchange with our president-elect, Michael Crowder, and Doug Rushton from the Pacific region, just talking about biochar, some possibilities. Years ago, because I've done work for Forestry Notes, which is an NACD publication, we did a feature on the Jefferson Conservation District in Colorado, which had done some work with biochar and just examined some possibilities. And so I think that this has always been a topic that's of interest for our audience and something where districts are curious to see if they fit, how it can be done, is it cost effective, what's the interest from landowners. And from this session, depending on the feedback we get and what we learn, I think there's potential not just for conservation district forestry, but even broader for our association to possibly explore this as something that could benefit landowners, and conservation districts could have a role in that. So a couple of notes, and then I'll introduce you to our presenters for this. We're going to have a Q&A session at the end where we'll take some thoughts. Don't just use that as an opportunity for questions, though. If you have experiences to share, something your district has worked in, or for our partners, if you have thoughts, ideas to share that's relevant for this, feel free to share those at that time. And you're going to submit those through the chat function. If you need to get to that, at the bottom of your screen, there's a little icon for chat. You can send those to the full group. I'll try to track those and then direct those to the speakers at the end after they're done presenting. And then I just ask that everybody keep on mute so we have clean audio. And this will be recorded. This is being recorded, I should say. So know you're on live camera, but also this will be available as a link later on that folks can download or access. If you know people, part of your network that were not able to attend, it can be shared with them. So with that, I'm going to jump in and introduce Charlotte Trowbridge as our first speaker. She's a Conservation Education Program Manager for Tualatin Soil and Water Conservation District. Did I butcher that? And based in Oregon, she coordinates educational opportunities to raise awareness on natural resources issues. A number of our Oregon districts have explored biochar and had workshops, so she'll talk a little bit about that experience and also her interaction with landowners. So Charlotte, I'll turn it over to you.
Sure, sounds great. Just wanted to make sure, Kelpie, had you planned on going first, or should I take it away? I'm cool either way.
I apologize. I think we did do it that way.
I had planned on going first, but it doesn't really matter.
Let me do that. My apologies. I had you listed first, but I think we did talk about that. Kelpie will introduce biochar, and Charlotte will talk about their experiences. Kelpie is our subject matter expert for biochar. And so one thing I found interesting in our conversations and looking for somebody that could really talk about not just the usage, but the production and the evolution of biochar as a subject. She has done this work, but more than that, she's familiar with conservation districts. She's worked with districts. Kelpie is an engineer and analyst with 30 years experience in renewable energy, sustainable forestry, and resource conservation. As a consultant, she's worked with forest managers, wood products industry, farmers, and conservationists to develop systems for making biochar from waste. She researches and teaches techniques for using biochar in compost and manure management, and presents many workshops. And her group is Wilson Biochar Associates. So Kelpie, I'll let you take it away.
All right, thank you, Mike. Let's see if I can get my screen shared here. And can you all see my screen? Is this working? Can you see my screen?
Yeah, it's visible. It's not, see if you can max, there you go. That's good.
Is that okay?
Yes.
All right. Okay, so I want to introduce you to biochar and tell you a little bit about what it is, how it works, and then what we've been doing with it for the past, quite a while now, a few years. So I have been doing biochar since 2007. I went to the very first biochar conference. It was in Australia. So I've been interested in it for a long time. My background before biochar was around forest conservation and renewable energy. So here's just a list of partners and projects I've worked with in the last maybe 5 years. And in the last 3 years, I've presented biochar workshops to over 2,000 people, mostly on the West Coast, but also in the Great Plains and Rocky Mountain states. So quite a variety of soil and water conservation districts, watershed councils, community partnerships, some commodity boards, and then state forestry services have been very interested for a number of reasons, and also federal agencies. I've done a fair amount of work with both U.S. Forest Service and the NRCS has been really important in the work that I've gotten to do. So let's just jump into what the heck is biochar? Well, the simple answer is it's just charcoal, but charcoal is there's a wide variety of charcoal materials. So it's charred biomass, so it can have a lot of different characteristics depending on the temperature that you make it from, what you make it from. But at the end of the day, it has to be charcoal that's suitable to add to soil. So some charcoal might have toxic elements in it, and this is a whole huge discussion, but it's basically biologically friendly charred biomass. What does it do when you put it in soil? Lots of different things. It adds long-lasting carbon and sequesters carbon in soil, number one. In many cases, it can help to conserve water. It can hold onto nutrients, keeping them in the root zone. It can have pH effects. It can be good or bad, depending on your soil. Ultimately, it promotes the soil microbial life. So it's really has a great benefit there. And in some cases, it can bind toxic elements in soil. So if you have a degraded soil, it can be very helpful. The picture shows really dramatic results from adding biochar to soils that were contaminated with heavy metals. Where did the idea come from for biochar? Well, most recently, in the last couple of decades, soil scientists realized there were these really quite large areas of very black, rich soil in the Amazon, which was unusual, unexpected, because the native soils are highly leached, reddish kind of soils, and not much carbon at all in them, because most of the carbon in a rainforest is in the living biomass. They found these, large extents of black soils and realized that they were made by people long ago, by burning biomass and adding it to soil. When I first started investigating biochar, I had a lot of questions about it. Was this hype or was it real? And the thing that really convinced me that it had to be real was realizing that there's a lot of natural charcoal in soils. And in fact, the very best soils, agricultural soils on the planet, the Iowa mollisols, half the carbon in them is charcoal. And that's because of the regular burning of the prairie. And so the tall prairie grasses would go off in a flash of heat, and then the flame would move by, and the near the roots, the thick bunches would char, and it would cool off, and the char would stay, and it would build up in the soil. Okay, so it's a good thing. It seems to help soil, but why? How does it work? Well, there's three main properties of biochar that contribute to its impact. The first one is stability. So when I first heard about biochar, also I thought, oh, it sounds like permanent compost. It's carbon you can put in soil and it doesn't go away very easily. So when you char biomass, basically you drive off all the volatile matter, the hydrogen and the oxygen, and you're left with just pure carbon, and that carbon fuses in these hexagonal ring shapes that are very stable. And what the chart shows you here is that when you char biomass, you immediately lose about half the carbon as carbon dioxide, but the rest of it is very stable. And in fact, this chart goes out 5 years. You could extend it out hundreds to thousands of years and not lose much of that carbon. Uncharred organic matter degrades more slowly, loses carbon more slowly, but within 5 to 10 years, most of it's going to be already back as CO2 in the atmosphere. And so this little diagram shows that how biochar works to sequester carbon. So you've got the natural carbon cycle, you know, vast amounts of carbon move in and out of the atmosphere to vegetation and soils every year, and then they go back as it's mineralized, as microbes eat it or it burns. In the biochar cycle, we intervene in this natural carbon cycle through pyrolysis, which is the technical term for creating biochar. So half that carbon goes right into the biochar and stays for a long time. The other half is released as gases, and you can actually use this. In fact, most biochar is produced as part of a biomass energy process. So half of that does go back to the atmosphere, but you can get energy out of it. So now the second property of biochar is looking at it at a microscopic and even at a nano scale. It has a large amount of surface area. So in this way, it's very similar to activated carbon, which most people are familiar with how activated carbon works. It has, you know, a teaspoon of activated carbon might have a football field's worth of surface area inside all those little pores. And so all that surface area is actually habitat for microbes. They can live on those surfaces, and those surfaces have special properties. They're electrically and chemically active. So that is the third property of biochar that's really important, which is electrical potential. So again, it talked about, you know, at the molecular level, biochar is carbon in a hexagonal ring, or what you might know of as a benzene ring. And the property of that benzene ring is that the electrons are shared around the molecule. So it has those electrons are mobile and contribute to conductivity and electrical potential. And this is something that I learned. You know, I'm a mechanical engineer, not a biologist. But in getting involved in biochar, I learned that there are microbes that can just live directly on electrons. So free electrons are really important to microbial life. And in fact, one of the benefits of biochar is habitat for microbes. So they've got these surfaces with free electrons. It promotes biological diversity of the microbes because they can do this interspecies electron transfer if they're on an electrically conductive surface, which is pretty neat. So you get more microbial diversity. And then you've got the food and water that biochar holds. So we call these luxury condos for microbes. Let me give you an example from my yard here. This is a bag of biochar that was sitting there for about 6 months. And last fall, I went to go and kind of clean it up. The rain was coming. I wanted to get it out of there. And I'm digging in this bag, and I'm seeing all these roots coming up. And, you know, it's full of roots. And look at these roots. The tiny root hairs are going right into the biochar particles. And so it's like, wow, this is pretty neat. Where are these roots coming from? Well, they were coming from those pine trees about 15 feet away. Not sure exactly what they wanted in there, if it was the moisture or the microbes or who knows, but the roots know what they want, and they liked biochar. So generally, biochar, when it's freshly made, is just a mineral product. It doesn't have any life in it, doesn't have any nutrients in it. It's not a fertilizer. So what we do is we want to charge it with nutrients and water to make it ready for soil. And the best way to do that is to compost it. Because you can get a lot of value out of using it as a compost additive. So I got a chance to really explore all these things with an NRCS Conservation Innovation Grant that we did here starting in 2016. And we worked with about a dozen small farmers who had forest land, small woodlots. and also had livestock. And so the idea was to use it to the biochar that we made to help manage manure in the barn and make compost. So here's an example of one of the compost piles we made, which was layered with biochar and, sorry, I got it. Somebody's trying to call me. Layered with biochar and manure and straw and so forth. And you can see in the little graph on the bottom that it followed what we expected, where with biochar, it tends to heat up faster and get a little hotter and finish quicker. And so it really helps with the compost making process. I've also found I don't need to turn my compost anymore because the biochar holds air and water in it. But what else happens what happens to the biochar when you compost it is that the microbes move in, the nutrients and moisture start coating the surfaces of the biochar, and the microbes live there and make their deposits of excretions and so forth. And so you get this organic coating that is actual, plant food, and makes a wonderful fertilizer. Part of our project was to do a lot of pot trials and testing different compost and biochar mixes that we made. And here's one where this same pile here, we picked those chunks out of the pile when it was done, ground them up, put about 2 tablespoons in each of these pots of a plain peat potting soil. I compared it to worm castings as a control. And you could see on the left, the composted char had better germination, it had more biomass, and it had more secondary leaves. So it had actually a growth stimulating impact. And this is just the char. Remember, it's not the compost itself, it's just the composted char. If I had put plain char in there, it might have had actually a slightly detrimental impact, because it tends to absorb what nitrogen is there. All right. So biochar's good stuff. Hopefully you agree with me now that it's really worth looking at. So where do you get it? Well, as I said, a lot of biochar that is available now comes from bioenergy power plants. So here's one in Oregon that produces quite a bit of char. And it's just the high carbon ash that's left over from the combustion process, and then they screen it. So they screen out the mineral ash, and it's just really a fairly pure carbon product, and it's really excellent stuff. And so, but how can you pay for it is a good question. It's not super expensive, but it is an input that you have to pay for. This is some really good news coming out of the NRCS right now. They have a new soil carbon amendment practice. It's still kind of being developed, but it is available. And this could actually provide cost share money to farmers and foresters to purchase biochar. So that is really good news. I wanted to let everyone know about that. But as I talked about our conservation innovation grant, biochar was not really so available 5 years ago. So we started on a process of trying to make our own. And we have in Oregon lots of fuels reduction projects that we end up with piles like this. So generally they're just burned in place as a disposal method, but we tried, first of all, different ways of making biochar from these piles. And the process that we use for making biochar in a burn pile or a flame cap kiln is what we call flame carbonization. So making biochar in an open flame. And the way this works is you have to understand that biomass burns in 3 stages. So the first stage is drying, and you can see in the little picture on the left, the steam coming out of that wet pile. And then the steam will turn to more of smoke. And the smoke is actually what burns in a flame. So that's wood gas or volatiles, or when it condenses, it becomes smoke. So what we try to do is burn it before it can condense and become smoke. And the flame provides the heat then to char the rest of the wood. So if you look at the picture of the log there on the right with the flame, you can see what we're doing here is we're slowly burning away the outside of the log to char the inside. So as the heat moves in, it converts it all to char. some of the out part of it to make the heat, to char the inside. And then at the end, when we made the char, we have to put it out before it burns all the way to ash. So that's the basic process. And here's the kiln that we first developed out of our Conservation Innovation Grant. We called it the Oregon Kiln. It's really meant for forestry uses. It's very robust. It has a bottom. You quench it with water, so it's got a drain. It's pretty heavy. It's more than 200 pounds, but 4 people can move it easily, and you can use it on uneven ground. So we got a lot of use out of these kilns. And here's a step-by-step how you would go about doing it. So first you put it in place, you load it full of small diameter slash, you light it on top, and then you just keep going. It'll take a few hours. You keep feeding the flame because you always want that hot flame on top to provide the heat and also burn the smoke. Then, when it's full, you let the flame die down, and you've got this whole bin full of hot flaming or burning coals, glowing coals. When they're just glowing, the flame is gone, that's the time to put it out. And then you put it out with water, and you've got biochar. So there's another support program that's been around for a couple of years now from NRCS through the Conservation Stewardship Program that provides cost share money for landowners to make this biochar from slash piles. And it's a good payment. It's more than $4,600 an acre. We have 3 or 4 landowners now in Oregon, California, and Washington who have used this. The CSP is a little hard to apply for, but if you have landowners in your district who are eligible, this is an excellent way to get started. And they need help. They're going to need your help to make this happen. Here's an example of a farm that would be a perfect candidate. And this is Tualatin Soil and Water Conservation District. Charlotte brought me back there. I've been there twice now. I was in October in 2019 and then in February this year. And so this is an overgrown Christmas tree farm in the rural areas outside of Portland, Oregon. It's a 100-head goat dairy. And all these Christmas trees got away from them. And they're really useless for anything. The goats can browse the needles a little bit, but then they're just all this wood they have to dispose of. So we did a 2-day workshop, a day of classroom, and a day in the field. And here we are helping these owners of Fraga Farm convert some of their wood into biochar. And we've got a few different kilns there. You can see different sizes of the Oregon kiln, and then another kiln in the background called the Ring of Fire kiln. And here we are, the farmer's got a load of biochar that he's taking up to the goat barn, where, by the way, they saw some really good results of reduced odors in the barn. Here's some other projects that I've done, workshops, the Two Rivers Soil and Water Conservation District here in Southern Oregon. Hold a neighborhood here, the Sunny Valley group, just a group of neighbors who've gotten together and, to help each other with fire protection. And they all got out together one day on a Saturday, and we made a lot of char from their burn piles. Here's the North Dakota Forest Service. Last November, I've also been in North Dakota a couple of times. This is an old water trough that they made into a kiln. Really, any kind of container will work. It doesn't have to be any special shape particularly. Very cold, but we did manage to make some char. And then this was in February in the Multnomah Soil and Water Conservation District, working in the rain, taking the biochar then at the end and adding it to a compost pile, and then the classroom session. And then this is the newest kiln design. So February, when I went up to Multnomah and also Tualatin again, that was the last biochar workshop I was able to do. My other workshops were canceled because of the COVID. So I'm like, well, what do I do now? And I'd had this idea for a new kiln design with an extra heat shield. So I had a welder make me up a couple of them. And all the kids were home from school and bored out of their minds. And so I said, can we work outside together and keep socially distant and test my kiln out? And they were willing. So we did like about 8 days of social distance biochar in April. So we've got a lot, live rurally, and I've got a lot of neighbors who are older but have woodlots they're trying to manage, and they end up with burn piles. And like these two ladies here, where that's hard for them to deal with burning a burn pile like that. So they were really happy to have these teenagers come. You can see the kiln is in pieces, and it's you can move it around easily and set it up anywhere you need to. And they took care of the burn pile, and they got paid for their work by the landowners. And so we did that, 8 days of that. It was really great. Great for the kids. Then actually in July, the people that I know who do a College Dreams STEM camp wanted to do a biochar theme for that. So we did 3 days of social distance day camp. And it was really successful. I think the kids were just really happy to be outside, but they seemed to really like the biochar and find it interesting. So we made biochar in a kiln. We did a stove competition making rocket stoves. We kept in 3 separate pods, of groups that were supposed to be separated. That was part of our strategy. When we got close to each other, we tried to wear face coverings. We did some lab work, soil lab, testing pH and other things. And the kids had a great time. I think the best thing was realizing when I saw that the girls thought that charcoal made good face paint, I knew we were successful. So that was a good time, and people seemed to really enjoy the biochar information and making it and using it. And so with that, I will close and just say, if there's any way I can help you with your programs, please let me know.
Okay, thanks, Kelpie. And with that, now we'll transition to Charlotte with Tualatin, and she can talk a little bit about her experiences with the district.
Sounds good. Let me just get my screen going. All right, is everyone seeing the new PowerPoint? Okay, cool. So I am glad that Kelpie went first, because I think having her kind of lay out the foundations of biochar helps make this part of the presentation make sense. This is really kind of the supplement to that, because I'm going to talk about sort of the ways that we've been engaging with our community to further this practice. So the title of this webinar is Biochar as a Growth Area, and I would say that we are definitely playing around with what that growth looks like and how we can get people interested and involved. So like Mike said, I'm Charlotte Trowbridge. I run our conservation education program. So that kind of gives you a hint that right now we're really at the outreach and education phase when it comes to biochar. So I'm going to kind of talk through the workshops we've been able to hold and give a sense for the interest we're seeing and who's coming to these events. And first I wanted to give some context. So we're in the northwest corner of Oregon, and I include that map on the right side to give a sense for what the land use is in our county. So we are just west of Portland, and it's pretty diverse in terms of we're about 15% rural, 15% urban, 35% rural and agriculture, and then 50% woodlands by land area. And I'm sharing this because when we started looking at biochar as a topic to educate on, we were actually just kind of focused on the rural agricultural community because that's where the topic came to us from. But then we were finding that we were drawing people from all across the county. It makes a ton of sense that woodland owners would be really clued into this, but then we were also finding that folks from urban areas who just had interest in learning or figuring out how to apply it in kind of an urban gardening sense were coming to our workshops as well. So there's a lot of interest across a lot of different land uses, which we're really excited about. So how did we get involved? Really, it came to us because of interest from local residents. So we don't have anyone on staff that was a biochar expert. We actually kind of had to put together a study group to figure out what's biochar all about. How do we even market this to people if we're going to offer a workshop? And so Kelpie had mentioned Fraga Farm, that goat farm. They were already experimenting around with producing biochar on their property. And we had a couple projects with them. And so they basically said, if you can get somebody here to give a workshop, we would let you host that on our property. So that was how it came to us. And they had said they'd already talked with a bunch of other small farmers in the area who were really interested. And so they kind of encouraged us to get moving on the biochar front. And as we looked into the topic, we found that there was lots of relevance to what our district is working on, partially because we work with a lot of landowners that just have a lot of feedstock that they don't know what to do with. So Kelpie mentioned fuels reduction projects. We do a lot of forest thinning. There's folks who are just piling up prunings and clippings. And then also we have a lot of old Christmas tree farms in the area, like Fraga Farm, the picture you saw earlier, where the Christmas tree market crashed a while ago. So now there's just these kind of aged out Christmas tree stands that people are trying to figure out what to do with. So this is great because it provides us with an option to give to people if they're looking to do something with that debris other than just creating burn piles. And in terms of local applications, it's pretty clear that there are all these links between biochar and soil health, and that is one of our #1 priorities as a conservation district. So the topic of biochar and educating on biochar really fits well with our goals. And so we have been supporting this practice primarily through education opportunities. So we've been able to offer two-day workshops with Kelpie. Both of those had one day in the classroom and then one day out on a site doing hands-on demonstrations and biochar production. I do want to caveat that we were lucky enough to be able to do that because we have Kelpie in the area. We've got an instructor who can come and lead that type of session. And then we also had really willing landowners both times who had a sufficient amount of feedstock. So if that's not something that your district has, focusing on a classroom session is still, there's tons of content there and some really cool kind of small scale demonstrations and science experiments that can take place in the classroom, even if pulling off a field day is not going to work. Then we've been noticing that through those education opportunities that we've offered, it's really allowed us to facilitate some networking amongst our community. So we're finding people at our workshops and after the fact kind of getting in touch with us to get in touch with other participants to talk about equipment sharing, compare notes about different kilns, really share some innovative ideas. And this can kind of help get at the economies of scale issue. So a lot of people had questions about like, at what scale is this actually a feasible practice? And so through that network, people are able to kind of sort that out, combine resources, and make this more feasible. And then we also, through those education opportunities, have been pointing people towards funding sources. So Kelpie mentioned the NRCS Conservation Stewardship Program, which, is a bit difficult to get going in, but we still like to pitch it to people. And then we have been able to offer financial assistance programs as well to help people out. So we did send out a survey before both of our workshops to figure out who's coming, like who's interested, why are they interested. So I wanted to share that information because it might help everyone else get a sense for who might plug into a topic like this. So we were seeing people from across the board. So woodland owners, gardeners, small farm owners, lots of people from the academic world, so students, researchers, people from the restoration ecology world. I've got wine industry up there because interestingly, we held our first workshop in October and we really geared that towards the small farm, small woodland crowd. And then we had some folks from the wine industry get in contact with us saying, this is something that we really should be doing. at vineyards, but you've held your workshop right in the middle of our harvest season. So that is why we ended up doing a second workshop in February to get a lot of the winemakers involved. And then, so in terms of why people are interested in biochar, I threw together just a little word cloud there of words that people threw out when we asked them this question. And front and center, the most common answer is soil improvement, which is great because it's showing that a lot of these people are already pretty clued into what the major benefits of biochar are. And we also see that people are looking at this across a variety of land uses. So in their woodlands, their gardens, their orchards, vineyards, farms. And then another common thread is that a lot of people are just looking for an option other than burn piles to deal with all their debris. So they're talking about their yard debris, their burn pile, their woody material, the burnable materials, prunings. So just looking for something other than just a classic burn. And then really quickly, I'll cruise through two little case studies. These are our two different workshop hosts. And so Kelpie has already talked about Fraga Farm, their goat farm that's converting their tree farm into pasture. And so their feedstock is these old Christmas trees. The application for biochar is that they're adding it as a soil amendment, using it as footing in their goat barn, which that's something that we've really been wanting to let people know about because we have lots of people in the area who are trying to deal with mud and manure management on their livestock properties. And then also it helps keep odors down in their barn. And then the second place we held a workshop was at a winery, which is a third generation farm that is using organic farming practices. And they're actively looking for ways to promote biodiversity and soil health. I noticed that they actually mentioned on their website that they hosted this workshop. So it's really part of their brand actually to be talking about practices like this. And so they're looking for something to do with all of their grapevine clippings and feeding that right back into the soil to boost their crop. And we're probably going to see some pretty innovative stuff out of them because they were already trying to figure out how they could maybe actually do their burning within rows if they created piles in a certain way and built kilns around it. So yeah, it seems like people are really interested in playing around to see how they can make this work. So to wrap up, I just kind of wanted to make the plug for engaging with people on this topic. We've had a lot of success reaching new audiences. We hadn't really been involved with the vineyard crowd prior to this workshop, so it's a good way to reach new people. And like I shared, we've seen interest across a variety of land uses, and just a lot of networking and people making connections. So our plans for the future are to continue hosting education and networking events, and then also to help people implement biochar projects through some of our cost share programs. But I'll wrap it up there, but would be happy to answer any questions.
All right, fantastic. We'll jump into questions. Again, if you have questions, add those into the chat function or thoughts and experiences. We do have a few already kind of loaded. Does the high surface area and electrostatic charges also equate to high cation exchange capacity as well as microbial habitat? That's almost above me. So that's from Cynthia. Probably Kelpie for answering that one.
Yes, it does. Biochar does contribute to high cation exchange capacity. And, it also, interestingly enough, once it gets microbial life moving in there and organic acids get deposited, it can also have anion exchange capacity. So your cations are the nitrates and potassium, things like that, and the anions are, I get them mixed up. But anyway, you end up being able to hold on to a lot of different things.
In terms of purchasing a kiln, Gary asked, where can you purchase one? I know that that's something you worked with, Kelpie. What are some options for people in different parts of the country? What's the best way to go about that process if you're interested?
Well, I have a lot of different resources available on my website, wilsonbiochar.com. So part of the Conservation Innovation Grant was, the deliverable for that was practice guidelines. Those are all up there. They're free to download, tell you how to use a kiln, how to use biochar and compost, but also there's shop drawings for kilns that you can take to a welder and have them made locally. So I did that originally on the Oregon kiln because I just couldn't figure out how to ship it. But actually right now I am starting to offer a kiln for sale. It's the Ring of Fire kiln. It's flat, ships flat. And so if you want to purchase a kiln, you can now order one from my website, and I'll be shipping those out in October. But if you're far away, shipping is going to be expensive, and if you might want to just make your own. The plans are free to download.
Okay. Is a soil question. What feedstock material is optimal for biochar used as a soil amendment growing food?
I would say whatever you have. It has to be practical, right? And some of the biochar researchers have found that actually straw and crop residue can make some of the most valuable biochar. Part of that is because it'll be higher in ash and higher in minerals and actual fertilizer. But if you have wood, the main difference between different wood species when you char them is density. So because you've really cooked out all the volatiles, so it's a pure carbon. So there'll be some physical differences due to density, but it's really, to get the value out of biochar, you have to have a value, kind of cascade of values. So the first value is doing something with my waste wood, So it's whatever you have, really.
Question from Mike Lasecki. Is there a shelf life for biochar after it's created? Will it lose some of its beneficial effects if it's produced and stored for long periods of time before it's applied to soils?
I don't think so. I usually leave my biochar after I make it. I leave it out in the rain, and that's good because it can rinse away some of the the ash, which you can have a little too much ash sometimes, and then it wets it, and when it's exposed to a natural environment, microbes do start to move into it, which is a good thing. It doesn't degrade really, so I don't think there's any problem with storing it for a long time. Just make sure you store it properly. If you have low temperature biochar with a lot of volatiles in it, and some moisture, it can actually ignite. So yeah, you want to if you're going to store biochar for a long time, be careful how you store it.
You were talking about wood density and qualities before. Gary in Mississippi wrote, we have charcoal makers in the local area using hardwood scrap. Is there any specific wood that makes better biochar?
Yeah, no, not really. I don't think so. I mean, there could be a problem. I think there were researchers at UC Davis who used walnut wood, or I'm not sure if it was wood or shells, but walnut trees have a compound called jugalones that are, forget the term, but it kind of poisons the soil for other things. So just, eucalyptus is like that too. So if you didn't cook it thoroughly, you might end up with some of those compounds. That could be a problem. But no, there are a variety differences in biochar materials. And what I found is if you add it to compost, you're going to take care of almost any problem that you might have adding a raw, unprocessed biochar to soil that might have either volatile residues in it, or too much ash, or a pH issue. If you just simply put it in your compost pile, it's going to take care of all of those issues.
Aaron asked, can biochar be used in conjunction with small-scale poultry operations?
Absolutely, sure. Lots of people have done this, and you put it in their pens and the coops, and it will start absorbing odors. And they'll actually also eat it usually, which is usually good for them. Biochar as an animal feed supplement is a real growing area.
Well, Charlotte, maybe this is one you comment on. What is the likelihood of a process for districts to adopt and incorporate biochar as an accepted or recommended management practice?
Yeah, that's a great question. I would say for our conservation district, we're definitely in the info gathering phase because there's a lot of questions that people have around return on investment or what scale makes the most sense. So for us right now, we're really only kind of seeing it or helping people implement the practice when it's in conjunction with other practices. So kind of part of a larger conservation plan on their property. But I do think with especially with what Kelpie showed us coming out of NRCS, the more incentives we can get in place there, the easier it'll be for conservation districts to see where it plugs in. So we're kind of doing some experimentation to see what the return on some of these projects are, and hopefully that'll inform whether it's something that we recommend more often when we're starting to work with landowners.
Okay, and it looks like that's our last question. We're just about out of time. I want to thank Kelpie and Charlotte. Again, this is a topic that I think both our RPG is exploring, but also NACD, and looking at, is this something that districts can work with landowners on, and what the potential is there. But thank you very much. It's been informative. And again, I'll note that this session is recorded, and a live link should be provided on the NACD website probably early next week. But thanks everyone for joining.